Hello, Argo. Welcome to Spirit Week. We're going to continue on a little bit with waves, but I do want to mention here, if you didn't get an opportunity, well, I put a couple Spirit Week videos of my own on the Spirit Week page in OneNote. I'd really be excited to see some other people send me some videos of their challenges. So I did the juggling the toilet paper, and I did the school song, fight song on the steel pan, so you can see those videos. Hey, but we're on to boundaries right now, and what I'm going to do is show you what we've got. It was some characteristics of boundaries, and there's going to be a quiz that you can take, but I'm going to walk you through how this thing goes. Here on the OneNote page, the first link is a tutorial. And if you'd like to go to that tutorial, it's got a lot of information. So what I would do if I were you, if you don't understand everything completely, or if you have a question, one of the things, if you like to read things, if you learn well by reading, you may want to try the tutorial. It's got quite a bit of information here, boundary conditions. It has some diagrams, it's got some links, it's got some animations and some videos. You'll see the different things if it's a fixed end or a free end. We'll go from less to more dense and from more dense to less dense. There's even some questions at the end to check your understanding. You may find that interesting. You may not. If you need help, go with it. The wave on the string, that is a simulation I'm going to show you just in a minute. But the really most helpful thing I think you're going to find in order to take this quiz is this chart. I think this chart will be really helpful and so this is what I'm going to use to walk through what's going on, and hopefully you will be able to follow it. If not, let me know, or read some of those other look at some of those other resources. So a boundary, what we have is a boundary. That's when we change from one medium to another. So when we change medium, remember the speed of a wave is determined by the medium. So when you change mediums, you change the speed of the wave. Some things change, some things don't, and the key thing is to know what happens. So at a boundary, you have a change in medium. And when we have that change in medium, there's two things that occur, and they both occur. It's an and. You get transmission, which means the wave goes into the new medium, and then you get reflection. Some of that wave comes back. And so the energy gets split into two different areas. The part of the wave that gets transmitted and part of that's reflected. So as a result, because part of the energy goes in and part of it gets reflected back, the amplitudes of each of these is less. So we have less amplitude. Both of them have less than the original wave. Now, you might end up with 50% being transmitted, 50% being reflected. You might have 95% being transmitted and 5% reflected, vice versa. It could be anything. They just add up to 100%. But how do you know if you have a lot of transmission or if you have very little transmission? Well, the key to that is you look at how similar they are. If they are very similar, you get lots of transmission. Okay. However, if they're very different, you get a lot of reflection. So when you yell and your voice bounces off a wall, the air and the wall are very different, you get a lot of reflection. Whereas you might have a situation where light can travel from one medium into another, and most all of it is transmitted because the two media are very similar. So if they're very similar, you get a high percentage of transmission. If they're very different, you get a large amount of reflection. Okay, now the reflected portion, when we look at it, because the reflected portion is in the same medium in which the incident wave, incident meaning the incoming wave, that incident wave, since it's in the same medium, it will have the same velocity, and the frequency will be the same, and the wavelength will be the same. Those things will all be the same for the reflected wave. Okay. However, on the transmitted side, those will not always be the case. Some things change, some things stay the same. Okay. Now, what we want to look at is when you get into the reflected, when we look at the reflected wave, then there's an or down here. Okay, that means one of these occurs. The reflected wave can come back inverted, or it can come back with the same orientation. And I want to help you to understand that. So what we have here is the idea. If the second medium is more dense than the first medium, it's going to get inverted. The reflected wave will be inverted. If the second medium is less dense than the first medium, then it's going to keep the same orientation. So let me show you how that occurs. I'm going to use this simulation here. And what I'm going to do is I'm going to use a fixed end. That's going to represent like the more dense. And when the second medium is more dense, it doesn't respond as quickly. Okay. And so what we have is I send the pulse, and what we'll find out is when you go to the more dense or this fixed end, you'll notice it got inverted. Okay, so both of these ends are fixed, and so every time this wave gets to the boundary, it gets inverted. Okay, it gets inverted. Now, if I choose to use a loose end, that's going to represent the second medium being less dense, and in this case, free to move. And so when I send that pulse, you'll notice that it keeps the same orientation. So it's up, it goes back. Now, the left side is fixed, and so at the left side of the simulation, it gets inverted. But on the right side of the simulation, it is a loose end representing the less dense medium, and therefore the orientation stays the same. Okay, so so that's what we mean by here on the right side of the chart. The reflected portion can get inverted if you're going into a more dense medium, and it'll come back with the same orientation if it's going into a less dense medium. That's the reflected portion, okay? Now, we get reflection, but we also have transmission, okay? If you speak and your voice hits the wall, some of that bounces back, but somebody on the other side of the wall still may be able to hear a small amount of it because a small amount of it gets transmitted, okay? Now, let's look at the transmission part. The transmission part is an or once again. Okay, it's an or once again, and that or will determine some other characteristics, and there are a lot of things here. So what we have, if the second medium is more dense, that means that medium can't respond as quickly, and then it will slow down. That means the velocity slows down. But the frequency is constant. The frequency is always constant. In all of these, the frequency is constant. Okay, it's always constant. And so if the frequency is constant and the velocity is decreased, then by the wave equation, v equals f lambda, or if you solve that for lambda, lambda equals v divided by f. If the numerator got smaller, decreased, then you'll recognize that the wavelength gets smaller. However, if the second medium is less dense, that means it is more responsive to that disturbance, then the velocity is going to increase. Once again, the frequency is constant, and by using the wave equation, the wavelength will increase. Okay? So that's what goes on in this chart. That tutorial walks you through the same stuff, but I think this is a little organized, maybe a little bit easier for you to use when it comes time for the quiz. And you've simply got to be able to look at the various scenarios. There's no math in the quiz. It's just a case of, does it increase? Does it decrease? Is it inverted? And you have to be able to use the chart. Okay? So hopefully the chart will help you out. If not, let me know. I can help you out as well.